All right, in this video, we're going to be talking about how to graph absolute value functions specifically using Desmos, and then what the different parts of the absolute value equation do as far as transformations. Do they shift it up and down? Do they shift it left and right? All of those things. So before we get started, I just want to remind you guys what an absolute value function is. So it looks like y equals the absolute value of x. And what that symbol means, the absolute value signs, those two vertical lines, is that we're talking about the distance between that number and 0. And since we always talk about distances as positive numbers, that means that whatever number gets put inside an absolute value symbol is always going to be forced to be positive. So we're going to say this makes the number positive. All right, so what we're going to do, and the reason why I'm recording this video with Zoom is because I want to show you how to graph these on Desmos, specifically with having numbers in as A and H and K, so you guys can see how to use Desmos with sliders. So if you go to desmos.com, you should be able to do it from a computer or from your cell phone. It's pretty mobile friendly. The app is pretty good. So we're going to click to graph. And what we're actually going to type in here is that entire equation, y equals a. And then you want to get those vertical lines in there. So shift, and then it's the backslash for this one, the one that's above the enter key. X minus h, another vertical line, plus k. And you'll see that it's giving you the option to add sliders for these. So if I click on them, it will give me a slider, and then it goes ahead and it graphs it for me. And so what it did is it took all those numbers and it made all of them +1. So it's pretty typical for a to be 1. If we want to look at the parent function for an absolute value, we're going to go back and make these 0 right here. So this is what an absolute value function looks like. It has a vertex right here at 0, 0, and then it goes over 1 up 1 to the point 1, 1. Or sorry, 1, 1's right here. 1, 1, 2, 2, 3, 3, 4, 4. Same thing this way. Left 1 up 1, left 2 up 2, left 3 up 3, left 4 up 4. So let's go ahead and put that in our notes. All right, so in our notes, we know that it was 0, 0, right 1 up 1, right 2 up 2, left 1 up 1, left 2 up 2. And so what we're going to do is we're going to, down here, we're going to sketch y equals the absolute value of x. And we're just going to draw that so that we have an example. They call this the parent function. The absolute value parent function, and you can write that on your notes if you want to, just so that you remember what that vocabulary term means. And the vertex is right here, the bottom of the V, it's where it switches directions, and that's the point 0, 0. All right, so now we're going to play with the sliders on Desmos so that we can see what each of these numbers does. All right, so if we look at A, you can go ahead and hit play and it will just mess with the numbers. So you can see that the A value can make the graph go straight up. It can make the graph go upside down. It does not move it left or right. It does not move it up and down. As you guys can see, that vertex is staying right there at 0, 0. And what I want you to notice about the size of the numbers here, I'll go ahead and hit pause, and I'm just going to put some specific numbers in there. If I put the number 5 in, if that's a positive A value, 5, or we could say 0.333, that's 1/3. Or I could say 4 or 2.5. You can see that all of those have the graph going up. So if the A value is positive, the absolute value graph goes up like it normally does. If I switch this A value and stick a negative in the front, it flips the graph upside down. The other thing you'll notice is as we make these numbers get bigger and bigger, so we'll go ahead and start. This is an A value of 1 is normal, so that's the normal absolute value graph, goes over 1 up 1, over 1 up 1. If I make the number bigger than that, you can see it just got a little bit taller and skinnier. Put a 3 in, even taller and skinnier, 4. It just keeps getting more and more narrow the bigger that number gets. So if the A value is positive, the absolute value graph goes up. If it's negative, the absolute value graph goes down. So now we can check out those negative values. -2, it made it a little bit narrower, even more narrow. So again, the size of the number is what makes it narrow. It's not the fact that it's negative or positive, it's the size. Those were big numbers, and so they made the graph really narrow. Now I want you guys to see what happens if you use fractions. So -0.5, so let's compare that. Let's put -1 in there. There's -1, there's -0.5, -0.33333, -0.25. So you can see those fractions make the graph look wider. So in this class, when we say that a graph is narrow, tall and skinny, we talk about that as vertically stretching it. It's going this way, so we call that a vertical stretch. Anytime we have a graph like this that's getting wide, we talk about that's like squishing it. We're compressing it, which is squishing it and making it wider. So we're going to go ahead and go back and put that in our notes. So for A, I'm going to say if it's positive, the graph goes up like this. And so as far as a transformation goes, that wouldn't be a transformation because that's normal. The graph normally does that. If it's negative, the graph goes down, and we say that the transformation that happened is it was reflected over the x-axis. So it normally goes up. If it reflects down like this, then that would be reflected over the x-axis. That would be negative. Next, if I'm going to put the absolute value of A, because for this part we said the sign didn't matter. It was the size of the number. Could be positive, could be negative. But the important part was that numbers that are bigger than 1 are vertically stretching. So think tall and skinny. Numbers that were less than 1 were vertically compressing. So we're thinking short and fat. All right, so we had a lot of information that came from that A value. What I want you guys to do next is I want you guys to play with the sliders, and you're gonna want to use whole numbers for this. Don't use decimals because that'll be frustrating. But I want you to come up with a graph that is right side up, and I want it to be tall and skinny. I want it to be vertically stretched. So come up with a graph that is right side up and is vertically stretched. And then I want you to come up with a graph that is upside down and vertically compressed. And what I mean by that is I want it to be short and fat. So go ahead and play with the sliders. I would recommend typing in numbers that are easier to graph. Like if you are just using crazy decimals, it's going to be harder to graph. If you want a vertical stretch and you put a 2 in there, that's going to be pretty easy for you to graph. So go ahead and pause the video and graph those. All right, so if you didn't know what to do there and you just want to copy what I did, that's totally fine. So here's my right side up. I can tell that it's right side up because it's positive in the front. It's a vertical stretch because 2, the size of the number 2 is bigger than 1. That's what makes it a stretch. And so from the vertex, it goes over 1 up 2, over 1 up 2. So that's how I'm seeing that stretch in there. The vertex has stayed the same because vertically stretching and compressing does not change that vertex. Right? So since this graph is upside down, we actually call that the being reflected over x. And so that's why I have a negative in the front. And then I did the fraction 1/3. And so when I graphed this, it went down 1 over 3, down 1 over 3. And it would actually continue to do that pattern. You just can't see off the grid. Again, my vertex is 0, 0. Okay, let's go ahead and switch back to Desmos and see what the H does. All right, so I'm gonna go ahead and put the A just at 1 so that we're not messing with that part. And then to see what the H does, I'll go ahead and press play right here and it will just move it. So you can see that the H value moves the graph left and right. And the part that's interesting about this is that if you look at the equation, it says minus H. So that means, and I'll show you in a second, we'll plug these numbers in. All right, so I'm gonna go down here, I'm gonna press enter just down there. All right, so I'm gonna do y equals absolute value of x minus 2. You can actually see that the graph is shifted to the right 2. That's because this says minus h, so you're minusing a positive number. So a positive h value, see how positive h values move it to the right? But there was a minus in the equation that made that happen. So this is x minus positive 2, which is what made it move to the right. So when we are looking at these graphs, if you have a minus inside, it's actually going to shift the graph to the right because it's minus a positive number. Over here, when you have your negative numbers, they're actually going to shift the graph to the left. So I said if x minus negative 2, that would move it to the left. But we all know that if you subtract a negative, that's the same thing as adding a number. And so this is the part that's a little bit tricky. If you see an x plus 2, it moves the graph to the left because it's actually a negative h value. If you see x minus a number, it actually moves the graph to the right because I don't know if it's going to be mirror image for you. If I see a minus, I'm actually going to be moving the graph to the right because it's subtracting a positive number. So let's go ahead and add that back to our notes. That's an important one. That's the one if a student is going to mess up one of the transformations, that's typically the one that's going to get messed up because it's a little bit confusing. So we're going to add that. So I'm going to put, if I see x plus a number, it is shifted to the left. If I see x minus a number, it is shifted to the right. All right, so what I want you guys to do next is play with the value for h, and I want you to shift the graph left. So take the graph, shift it left, go ahead and write it down. Again, I would probably use whole numbers or easy decimals to graph. So for mine, I had the equation y equals the absolute value of x plus 3, which shifted it to the left because the h value is actually negative 3. So if you want to write that example down, you can. I'll show you in a minute on Desmos what that one looks like just so you believe it. All right, so here's where we left Desmos. I'm going to go ahead and type this in, x plus 3. Okay, so you can see that's the one that I drew, but I'm just going to show you that really this is x minus negative 3. So you can see it's actually the exact same thing. So I'll get rid of that. There's the black one. It's the exact same thing as if I have minus negative 3. And over here I can just verify that again by showing you I'm plugging in negative 3 for h. All right, so that is actually the exact same graph. All right, now I'm going to go ahead and put the h. The h typically is at 0, actually. That's where the normal graph is, right at that vertex of 0, 0. So what we're going to do next is we're going to go ahead and press play on k just to see what the k value does. So the number on the end of the equation moves the graph up and down. And the nice thing about k is that it acts the way we would expect it to act. So you can see those negative values are moving it down. Here's positive k values, they're moving it up. So we're going to go back to our notes. And up here, we're going to say that positive numbers, I'm going to go ahead and write x plus a number, shifted up. and absolute value of x minus a number shifted down. All right, so for these last two examples, here I want you to draw a graph that is upside down and shifted down. And then here I want you to draw a graph that is shifted to the right and up. So go ahead and play with the sliders on Desmos until you can find a graph that has been shifted, that's upside down and shifted down, that's shifted to the right and up, and draw those for each of those last two examples. All right, so here are the two that I chose to do. To shift it upside down, I stuck a negative in front of the absolute value. I made it so that my A value was -1. And then to shift it down, I used a K value of -2. So I shifted it down 2 and it's upside down. That means that the vertex is 0, -2. And then over here, I used an H value of +1, which inside the absolute value symbol ends up being x minus 1. And then to shift it up, I use a K's value of 3, and my vertex ended up being 1, 3. So what you might notice if you were looking at the vertex is that the x coordinate of the vertex is always the opposite sign of what's inside the parentheses. And the y coordinate of the vertex is always the number on the end. So -2 on the end, +3 on the end. Here, the x and the y coordinates were just 0 and 0 because there was no number inside, there was no number on the end. So the way that I find the vertex is I go up here and I do the opposite of this number. So if it's positive, I do negative. If it's negative, I do positive. And then I do exactly the same as that number. So the vertex is always HK. And that will be true, all of this stuff that we've learned, this will be true for absolute value functions, which is what we're doing right now first. Then we're going to shift over and do quadratics. It will be true for those. It's true for cubics. It's true for square root. It's true for all sorts of different parent functions. So this lesson right here is important because we're going to use this for the rest of the semester, the rest of the year, really. All right, go ahead and flip the page over. We've got some more examples to do on the back of this. All right, so first I want to go through and write down the transformations and make sure that I remember what they are. So this is an A value in front. It's positive. That means the graph is going to go up, and it's 2, so that means it's a vertical stretch. So this is a vertical stretch of 2. There's the H value inside. It moves the graph left and right, and it's the opposite of what I would think. So since this is a negative, that means it's shifting it to the right 3. And then this number on the end shifts the graph up and down. That's a -1, so it's down 1. All right, so I've shifted the graph to the right 3 and down 1, so I know that this is where the vertex is going to be. So it's the opposite of this number and exactly the same as that number. So I know the vertex is +3, -1. All right, so I graphed it at +3, -1. A typical absolute value graph goes right 1, up 1, right 1, up 1. This one is twice as tall, so it's going to go right 1, up 2. Now, I have them all memorized. I'm a math teacher, so I know all the rules for this, but you're not math teachers, and you maybe don't want to be mathematicians, and so it's okay if you don't want to memorize all these rules. So for you guys, you can use Desmos to go ahead and graph these. So if I wanted to use Desmos, I'm just going to go up here and get rid of everything I typed already. You can just type y equals 2, get those vertical lines in there. And then you can look through and so what I'm doing here is I'm zooming in. You can see that it starts at 3, -1. If you click on that vertex, it'll actually tell you what it is. And then I can see that it goes over 1, up 2. I can see it goes over 1, up 2. So that's the nice thing about Desmos is you can kind of zoom in and out. It's pretty user-friendly. If you're using your cell phone, you should be able to like pinch and stuff to zoom in and out. You can click and you can hold your finger on it and drag and it'll move the graph around. If you're on a computer, you're just going to use your mouse to do that. All right, so let's go back to our notes and finish filling out the rest of the information we want. All right, so we have the vertex already. If I'm looking at this, this is an equation. So if I wanted to say what a solution was, then I can look at any point that actually shows up on that line. So I'm going to go ahead and use this point right here, 0, 5. And I want to show you guys how to check the solution because we are going to be graphing absolute value inequalities, just to make sure we know how to do absolute value graphs and do the inequalities with the dotted line and solid line and shading. And I have found that students have a hard time plugging numbers into absolute value functions correctly. So I just want to make sure that that makes sense. So I'm going to say the y value equals 2 times the absolute value of the x value minus 3 minus 1. So what I'm going to do first is I'm going to simplify what's inside the absolute value symbols. So 0 minus 3 is -3. And then this is the point where I get to use the absolute value symbol the way that it's supposed to be used. So the number inside of an absolute value symbol becomes positive. So I've got 5 equals 2 times, these are written right next to each other, so they're going to be multiplied, 2 times 3 minus 1. So that's 6 minus 1, and then we get 5 equals 5, which is what we expected. So we know, just like with our linear functions, any point that shows up on the line is going to be an actual solution for the equation. All right, let's go ahead and do this next example. This one is negative, so it's been reflected over the x-axis. That means it's going to be upside down. The size of the a value is smaller than 1. That means that the graph is going to be compressed. It's going to be short and fat. So we're going to say vertical compression of 1/2. The number inside the absolute value symbol is a plus, and so that means we're going to do the opposite of that. We're going to move left 1. And then there was no number on the end. I'm going to go ahead and put a little +0 because that helps me. There is no number on the end, so this graph does not move up or down. All right, so if the vertex is normally at 0, 0, and it does not move up or down, but it goes to the left 1, then that's your vertex right there. I'm going to go ahead and show how we would have found this without graphing it. So -1 and then 0. Okay, and then it's been reflected over x, so instead of going up, it's going to go down. And then these graphs normally go over 1, down 1, over 1, down 1. But this graph is going to be half as tall as normal, so it's going to go over 2, down 1, over 2, down 1. So it's going to give it that squish, that compression. Right? And I want to show you guys how to plug a point into this one as well. So we're going to check another solution. We're going to use -3, -1 this time. So I'm plugging in the y value for y, -1 equals -1/2 times the x value plus 1. And I don't need to put the +0 because it's not going to do anything anyway. All right, so -3 plus 1 is -2. The absolute value of -2 is a +2. These two things are written right next to each other. That means they're being multiplied together. And then I know that my answer is going to be negative because there's a negative in the front. And then I'm saying 1/2 of 2. And 1/2 of 2 is just 1. So -1 equals -1, which is what we expected. All right, we've got one last problem on here to graph. So this one, it's got a 4 in the front. It's positive, so that means it's going to be right side up. That's a bigger number, so it's going to be a stretch. It's going to be stretched by 4. There is no number inside. Sometimes when I see this, I like to rewrite these with a 0 inside. That just helps me when I find my vertex. So that means that that graph has not been shifted left or right at all. But it does have a -5 on the end. That means it's gone down 5. So from the normal vertex of 0, 0, not left or right at all, just going down 5. It's right here at the very bottom. And so if I look at the equation for that vertex, I would see 0, -5. So the vertex is 0, -5. And then from there, a normal absolute value graph would go over 1, up 1, over 1, up 1. This one is stretched by 4, so it's going to go over 1, up 4. Over 1, up 4. So this is a very tall, skinny graph. And then we have to be careful because this is an inequality, and the inequality symbol tells us that this should be dotted. So I'm going to draw a dotted line right here. All right, so there's my absolute value graph. Now I need to figure out where to shade. So when we have lines, we would say like, okay, I'm going to shade above the line or below the line, or maybe we would say the left side versus the right side. When you have a V-shaped graph, the way that you think about your shading is you can shade inside the V or you can shade outside of the V. And so what we're going to do is we're going to pick a point that's either inside the V or outside the V, it doesn't matter, and then we'll figure out which side is true and which side is false. So I'm going to go ahead and use the point -4, 1. And I don't know if it's a solution or not, so I'm not labeling it as anything. So I'm going to plug 1 in for y. I've got 4 times the x value minus 5. Now that x value is in absolute value symbols. The absolute value of -4 is just +4. These two are written right next to each other, so that means we're multiplying. That's 16 minus 5, and that's 11. 1 is greater than 11, that's false. Okay, so the point -4, 1 is over here. This is false. So that means that outside of the absolute value is false, which means that inside the absolute value is true. So that's where the shading goes, is right inside the absolute value graph.